All right, so here's the second part of balancing chemical equations. So the last video I showed you one method of figuring this out. Now this video I'm going to show you another method that we could use to balance chemical equations. Now this method takes a little bit more, it's a little bit more algebra, all right? The cool thing about this method, the pro about it, it takes the guessing part out of the picture. So as long as you know how to work algebra type questions like solving for the missing variable, you'll do just fine. Now the con about this, it takes a little bit more setup, all right, and oftentimes it takes a little bit more time to go through, but as I said, you'll get the answer the very first time. So the pros about the trial and error is that, it's quicker. Usually those who are a little bit more number savvy, they could easily see it and they could find the answers much quicker using the trial and error. But the con about it is that you could easily be wrong, all right? And so you really have to make sure you check yourself over and over again to make sure that, it is the correct answer, all right? Versus this algebra way, which I'm going to show you, it takes the guess and check out of the picture, and typically if you do it right, it is right. Okay, so let's kind of go back, looking at the equation I did last time. The C4H10 plus O2 yields CO2 plus H2O. All right, and let's use this new method of figuring this out. So the first thing you're going to do, for each of the blanks where the coefficients are supposed to be, you'll label it as a variable. So depending on how many coefficients or how many blanks you have depends on how many variables you have. All right, so some equations may only have 3 coefficients, so you will have 3 variables. Some equations you have 10 coefficients and you have 10 variables. It all depends. You start from A and you just move on until you have assigned each coefficient or each blank a variable. Okay, now the second thing that you're going to do, you're going to list each of the elements that you have. All right, so I have 3 elements overall. We have a carbon, we have a hydrogen, and we have an oxygen. Okay, now what we're going to do, we're going to create expressions, algebraic expressions, with the relations of the element and the variable that is associated with it. Okay, so what do I mean by that? First, let's look at carbon. Okay, now we look at an equation where we find carbon, and carbon is found in 2 spots, and you should always find the element in both the reactant and the product side, obviously. But here, if you notice, you find carbon in 2 specific spots. There's carbon here, and there's carbon here. Okay, now this first carbon is associated to the variable A, okay? And so the way that we write this is that there's 4, looking at this number specifically, 4, and the variable 4A, okay? Now, once you cross the arrow, you'll write an equal sign, and then we'll go to the second carbon. So this second carbon doesn't have a variable, all right? So it's an understood 1C. So this is our algebraic expression for carbon. And we'll do that for each of the elements that we have. Now we have H. All right, now for H, there's several places that you find H on the, let me get an eraser. Several places that you find H on this chemical equation, all right? Well, actually, there's only 2 places. And so I'm just going to kind of highlight that for you. For H, we have H here, and we have H here. And we're going to create expressions using the variables that this hydrogen is associated with. So this first one, we have 10 hydrogens, 10A. We cross this arrow, equal sign, and then this one here is a 2 and it's associated with this D. So it's 2D, all right? So that is the expression for hydrogen. And last but not least, let's write the expression for oxygen. Okay, so for oxygen, we have 2 places. Actually, there's 3 places that we find oxygen. We find oxygen here, here, and here. Okay, so let's look at this first one. So here you have O2, so 2B. You cross this middle, this arrow equals. All right, here we have a 2C plus 1D. Oh, did I write a C here? Wow. So it's supposed to be 2C, apologize, plus D, or 1D, okay? So here are our expressions for each of the elements that we have in the periodic table, or in this, periodic table, in this chemical equation, all right? Now, what we're going to do now, using these expressions, we're going to solve for each of the variables. All right, so on the side here, I'm going to write out each of my variables, okay? And I'm going to solve for each and every single one of them. So the very first thing that you do at this point, you're going to make one of the variables 1, okay? Now, in some cases, it doesn't really matter. Sometimes, depending on which you call 1, you'll make the math a little bit more difficult, just depending on how you're going to solve for each of the following variables, all right? Or if you're, once again, kind of math savvy, if you kind of look through these 3 equations, you could kind of see which one is probably best to call 1, simply because it'll just be easier to kind of figure things out, all right? So in this case, let's see which one I would call 1. And it doesn't really matter. I'll just choose one, all right? And just for the sake, I would say I'm going to make A equals to 1. Now that A is equal to 1, I could solve for each of these variables. So like, for example, okay, I made A 1, so I could use this first equation to solve for C, okay? So if A is 1, then we could say that 4, once again, A is 1, 4 times 1 equals C, right? So in this case, C is 4, okay? Now, we know what A is, so we could solve for D, okay? So in this case, 10 times 1, because A is 1, equals 2D. All right, so for this equation, solve for D. So we divide out this 2, cancel it out, divide out this 2. So 10 divided by 2 is 5. So we know D is equal to 5, okay? Now, we could go, now that we know what A, C, and D is, we could go ahead and solve for this equation, because then it would give us B. We know what C is, and we know what D is, so we could figure out B is. All right, so in this case, I'm going to kind of move this. All right, in this case, we have 2B equals 2. C is 4, plus D is 5. All right, and so let's solve for B. So 2B is equal to 4 times 2 is 8. 8 plus 5, all right? 2B is 8 plus 5 is 13, all right? So we divide the 2 out. So we know that B is equal to 13 over 2. All right, and I typically like to keep things in fractions because it's just easier for me. 13 over 2. Now, so when you're looking at this, right, these variables are the coefficients. So what you're saying that A is 1, B is 13 over 2, C is 4, and then D is 5, all right? But the problem with that, we never find fractions or decimals as for coefficients. So what we need to do, we need to figure out a way how to change B, which is a fraction, to a non-fraction number. All right, and the way that you typically do that is you multiply by its denominator. So the denominator of this is 2, so I'm going to multiply this whole thing by 2. When you do that, 13 halves times 2 is just 13. What you do to one, you do to all. So I got to multiply each of these by 2, okay? So 1 times 2 is 2, 4 times 2 is 8, 5 times 2 is 10. And just like I said before, these, all right, are your variables, all right? So since A is 2, we'll write a 2 here. Since B is 13, I'm going to write a 13 here. Since C is 8, I'm going to write an 8 here. And since D is 10, I'm going to write a 10 here. And hopefully, if you recall, this looks like just like the answer to the very last problem I gave you in the part 1 of balancing chemical equations. All right, and so this is the guess and check method. All right, we'll do one more. All right, so let's look at this final example, okay? And once again, we're just going to use the algebraic way to figure this one out. All right, so we have A, B, C, D. So we have 4 different coefficients, 4 different blanks. So we have 4 different variables. So the first thing we're going to do, like I said before, is that you're going to list out each of the elements that we have. So we have sodium, we have carbon, we have oxygen, we have calcium, and we have phosphorus. So we have 5 different elements here. And with these 5 different elements, we're going to create algebraic expressions based off of the elements and its corresponding variable. Okay, so let's first look at sodium. So that we see sodium here, on the left side, we have 2A equal 3C. Okay, so that is the expression that we have for sodium. Now for carbon, we have, there's only 1 carbon here, so it's A equal, there's only 1 carbon here, so it's D. A equals D, okay? For oxygen, we have, so oxygen is kind of a complicated one in this case. So we have 3A plus, so you have this oxygen that's in this parentheses. So we have to multiply this first. So 2 times 4 is 8. So we have plus 8B equals, all right, equals 4C plus, okay, 3D. So this one's a little bit more involved, okay? All right, then we have to look at calcium, all right? So we notice that calcium is only in 2 spots in this whole entire thing. And as I'm trying to erase all this, okay? So calcium, we have here, so it's 3B equals, so there's an understood 1, so 3B equals D. And then last but not least, we have phosphorus. All right, so for phosphorus is inside this parentheses here, so we have to distribute the 2, and it's 2 to this no subscript there, so that's a 1. So in this case, it is 2B equals, there's only 1 of this, so equals C. All right, so this is our expressions for each one. And now what we're going to do is that we're going to write out each of the variables. So you have A, B, C, and D. And now what we're going to try to do is solve for each one. Now remember, I told you the very first step that you want to take is that you want to make one of them 1, okay? And then after that, hopefully it becomes easier to kind of figure out what's what. Okay, so like for example, I'm just kind of looking through each of these expressions, and I honestly think it would be better if I make B1, okay? The reason why I said that, if I look at this, if I make B1 here, if I do the math, then, you know, D is simply going to be 3, and it's the same thing here. If I make B1, then C will simply be 2, okay? So I make B1, and let me show exactly what I'm talking about here. So if B is 1, then 3, substitute the 1 for B, or substitute B for 1. So 3 times 1 equals D, right? So now we know D is 3. In this case, we do the same thing here. So substitute it. 2 times 1 is equal to C. All right, so that means C is 2. Okay? Now, the only thing that left that we have to solve for is A. You have 2 different equations you could choose from, right? We could use this one, or we could use this one. honestly, I think this one would be easier. All right, because A is equal to, and we'll substitute 3 for D, or D for 3. However, doesn't matter. A is 3. Okay, so now we plug these numbers back up here. And what we can do, if you truly want to, you could just double check. All right, so let's look at sodium first. So in this case for sodium, all right, we see that we have 3 times 2 is 6. All right, 2 times 3 is 6. Cool, we're good here. Let's look at carbon. Carbon is 3, right? 3 for this one here, so there's 3 carbons. Perfect. All right, let's look at calcium. Calcium, we have a 3 here, well, this is 1. Calcium is 3 times this 1 here, so we have 3 here. So we're good. Let's look at phosphorus. Phosphorus, you have this 1 here, you have this 2 here, so this is 2 phosphorus. Here we have this 2 for this 1, so there's also 2 phosphorus on the right side. So we're good. And last one, let's look at our oxygen. Oxygen, we have this 3 times 3, it's 9, plus, all right, so 2, there's 4 here. So what's that, 4 times 2? You have 8, so 8 plus 9. Doing my math right. We have 17, okay? So let's look at this side. We have 2, 4, 8. All right, you have this 3, 9. So 8 plus 9 again is 17. So everything is accounted for. All right, so this is just the algebraic way of balancing chemical reactions.